Hello, everybody. This is the SMC Journal podcast where we're talking about software engineering in the enterprise, DevOps, performance testing, tuning, optimization, AIOps, and observability, and much, much more on the program. I'm Scott Moore, your host, and I appreciate you being with me. Today's show is a little bit different because we're going to be talking about hardware. I know many of you have probably thought, Scott Moore being the awesome performance engineer that he is, how would he build his own server? Well, today's show is going to answer that question. So it goes back to over the last holiday season in the December, January timeframe when I had some time off. This is what I do on my time off. I thought, you know what? I want to build my own virtualization server. It was not that long ago that I had a specific cloud provider and I'd built several machines, virtual machines running on this cloud provider. And they decided to change their licensing model almost overnight and say, you know what? You're not going to get that great deal anymore, Scott. We're shutting off all of your machines. And if you want them back, you can pay us X amount of dollars. We're converting over this licensing model. So I let the machines go. I could always try to put those machines on another cloud provider, but I started thinking about the cost of that. And I want to build out demo machines. I want to build out temporary machines that I can test out and then destroy anyway. And I really didn't want the hassle of building that inside of AWS. I mean, I could, and I could do that as an extension of what I want to do. But I also wanted some machines for web development of machines that were going to always be running and I could get to them anytime I want to. And I didn't want to have to turn them off and on to save money. So long story short, I decided to build my own rack mount virtualization server. And I did what any anal retentive performance engineer does on their time off, a lot of web research and a lot of YouTube watching of people who have been before me and have successfully built some servers. Now, I had specific requirements. Obviously, this is going to be a virtualization server, so that's different than, say, a gaming system. I also wanted to pay attention to how much power I was consuming and how much noise the server was making because I'm a content creator and I need to be in a quiet space. And I didn't want 600, 800 watt power supplies with large fans running in the background and going, I didn't want that. And I also just wanted to consume less power as well and monitor that. I only wanted to run about 6 virtual machines, maybe a couple of containers, and they don't all have to be running at the same time. But I do want a couple of machines running for web development that I might want to just wake up at 2 a.m. in the morning and start coding on, right? So little things I wanted to run experiments on. This was made for me. So this is the story about how I put that server together, and I've had this footage in the can for several months, but this is the first time I've been able to share it with you. And this is part 1 of a 2-part series. Talk about putting together the hardware first. And this is the basic minimal setup that I needed to make this work. And then we'll talk about the software at another time. So let's go to that video footage now and watch how a performance engineer decides to build his own virtualization server. Okay, let's start with the case. I'm not going to go through a long put together video. I'm actually just going to show you the stuff that I used, references. I'm not going to go through a bunch of long model names with characters and letters and things. To me, it just sounds goofy. I just want to put together this machine as fast as I can, but you don't want to see me getting in there with a screwdriver, but I did want to show you the equipment that I'm using. I will be referencing the place where I originally saw this put together and where I deviate from this, but this is a case. It's a very basic one, but it does have a lot of ventilation and it's probably going to meet my needs pretty good. We've got the top insulation here, and I'm just going to take this off and show you the insides of it. Bare bones basic case, but again, good insulation in the front here as well as the top and then the back. I'm actually going to have a spacer in my rack for the top of this, so nothing will go immediately on top of this, so there will be air commands, but I'm not going to have a whole lot of stuff in this. Remember, efficiency, less heat, less stuff running, all the better. So I will be putting 1 case fan in here, and that's going to be it for heat dissipation, other than trying to keep everything as minimal inside to produce heat as possible. Now, if I find that heat is going to be a problem long term, I will be adding another case fan. I've also got a provision for putting in a CPU fan that's basically sitting on top of the fanless design. In other words, there's the big heat sink, which you'll see on the motherboard, and I'm going to have a piece 3D printed that sits on top of here that will extract air and get it moved out of this case, if that seems to be a problem. But we're going to find out, and obviously there'll be an update of this. But great Starlink case. Now, after watching the videos of other people putting this together, I think what I'm going to do is take out these two drive bays, just unmount them, take out the fan cover here piece and mount the fan in here, put it back, and then I'm going to put the power supply in, put the shield for the motherboard that I've already punched out the right pieces, and then we'll go to the motherboard, put everything on it, and then we'll mount the motherboard last. But I want to put everything in here and get it situated before I go any further. So let's start with that. So let's talk about the motherboard for just a second. You can see on the original Learn Linux TV, the board that he chose with the AMD processor already in. This is a server board, it's a mini ITX board, clocks in at about 55 watts. You can see all the reasons why he chose that. I chose it for pretty much the same reason, but I didn't stop at just looking at the video that he did. I actually went on the internet and started looking at articles where there were reviews from people who actually do virtualization all the time. They have their own home labs. They've been doing this for a while. And even though this particular board has been out for a couple of years now, it's still a really good choice. Somebody actually just a couple of months ago in late 2022 said, is it still worth using as a virtualization motherboard? And they said after looking at all the other options, it was the best. Now, the only negative part of this board is it was a premium cost. I did buy it off of Amazon. I'll share the links to this board out there, and I'll make sure all the model numbers are showing up here. The main thing I want to get across is I chose to go with the fanless heatsink design because no fans, no noise, but I do know that it is going to generate heat. So if need be, we'll put a fan on top of that, a 60mm fan. I'll actually show you the Nocturna fan that I'm going to be using. And I wanted to also just show you some of the other pieces that are going to be in this. So the other reason why I chose this is because it has 4 1 gig NIC cards already built in. It also has an IPMI remote management slot. So IP, go to a website, log into this server, even to turn it on. It's been so long since I put together a machine that wasn't even available back then. Last time I did it. We also have some USB, but the main thing is it's got everything that I need in such a small footprint. I mean, this actual 2U rack case that I'm using is probably overkill. A lot of things that I do is probably overkill, but remember, this is a Performance Engineers virtualization build. Now, another thing I want to talk about that I'm going to be using on this board is something called a SATA DOM, and this is not something I've ever used before, and it's something new to me. Started looking it up on the Microserver website, and this is an alternative boot device. I don't want to boot my Proxmox or even ESXi off of a USB or even use up an SSD slot or anything. This is a very small footprint, and it does work well for this. And I know for ESXi, it's pretty much just a read-only disk. There is some writing that gets done to this, but Microserver recommends it, says it's okay to do writing to this if need be. And you can actually see here, there's a different color slot here. So I have actually 4 of these connectors here, these SATA slots, and I'm actually going to use this one for the SATA DOM. So this is what I'm going to use to boot up with Proxmox, or if I were to choose ESXi, I could do that as well. It's going to take up one of my slots, but I'm not even going to use any of these other ones right now. In the future, maybe I will. If I need additional storage, I may add another terabyte or 2 terabyte fast SSD, very small footprint. But what I'm actually going to use for the storage of my virtual machines is going to be this guy right here, which is the pretty new Samsung 990 Pro NVMe, I guess is how you pronounce it, drive. I chose this one because it has about 40 to 50% less energy used, which means less heat produced. So maybe I won't need that additional case fan, maybe just the CPU fan. I'll also mention that I am going to be using the Crucial RAM that was recommended for this on several forums, as well as I believe this is the same RAM that was used by Learn Linux TV. I'm using 128 gigs of RAM. I want to run about 10 virtual machines constantly. I may have more defined, may not have them all running at the same time, probably have some Lexi containers running, may have some Docker containers running, who knows what I'm going to run out there. But I think the 128 gigs of RAM is plenty. Last thing is there is a connector that comes with this microserver motherboard that plugs into the power supply. This particular power supply connector then will go into the motherboard in a there's 4 pins down here, and I'm looking for it, and it looks like it's going to go right there. So I'm going to go ahead and plug all of this in and get this ready to mount inside the drive. I'm going to go ahead and put my RAM in, and then we'll continue on. Okay, so as you can see, I've got the final prep work here for, I think I'm done. I have the power supply in. I have tucked all the cables I'm not going to be using, which is mostly to any PCIe or drives, anything like that. Those are all tucked in here. There was only one real cable that I needed to do, which I've shown is this white connector here that plugs into the motherboard. I've kind of tied it off. I'm not going to have any drives here or anything like that. Put these back on. The fan is secure. Everything looks okay. There's a couple of things that I'll mention here. I used a combination of this, right? So this is just your regular screwdriver, automatic screwdriver to save you from doing this, but there are times when you're going to need a smaller thing like that, as well as different sizes here. The only thing I can say about this, it was very difficult putting in some of the little tiny screws in little tiny places. If this had sort of a magnetic type head where it would hold the screw in place where you could get it into the little hole and twist it, would be much easier. Nobody ever mentions that. I don't put together a lot of boards, so I'm sure guys who do this all the time, this is no big deal for you, but this was just a little bit of a challenge for me. Everything went on the board. Everything looks right as far as where the major pieces should go. Another thing I'll mention is with this board comes the instructions for where everything is supposed to go, like the whole mapping of the motherboard. And this is real common when you get a motherboard, obviously, but not having put one together in a few years, it was just a little challenging. And also needing these or taking pictures of this with the phone and blowing up. I just wish this was a little bit bigger for those of us that are challenged on the eyesight here. But basically it tells you where everything is at, and then the biggest piece is, if you're not used to doing this, is there's this area here where the case, the server case itself, has power switches and LED indicators. Those are sitting here on the front, and like when you mash the reset button or the power button on the server, those little cables have to be plugged into little jumper things of the on the motherboard. There's also this cable that goes to the 2 USB for the front. You've got the USB in the back, but you've also got USBs in the front. Those connect to a cable that's right here. So I think I got this all right. If I found out that I didn't, I'm going to be changing it. You'll also notice that these jumpers are over here. It tells you on this sheet of paper which jumpers are enabled. And one thing to note is if you are trying to save every single bit of wattage off of this board, you can actually save another half a watt if you take one of these jumpers here and disable the VGA connector on the back. So I'm never going to use this VGA. I'm always going to use IPMI to remote in and do everything. I could always turn it back on if I wanted to. So I'll just note that I'm not going to disable it because I don't want to mess with jumpers. Probably need some tweezers for that. The other thing to mention is this is going to be upgradable for the future for me. I've got a CPU that's built in, so I'm stuck with that, but it's 8 cores, 16 threads. That's nothing to laugh at, especially for a board this size. I'm actually going to show you this is my iPhone, right? This is like an iPhone 12, and that's how big the board is. So size-wise, this is really small, and as you can see, with nothing else in there, there's complete open airflow here. There's a fan that's supposed to be very quiet for this power supply, and the one fan, the Noctua, is supposed to be, I hope I'm pronouncing that right, that's supposed to be sort of a silent fan, or as quiet as you can get. I'm hoping that it pushes enough air through. As I've said before, if it doesn't, I'll put another one here, and I plan on putting a CPU fan on top of this heat sink there if I need to suck air out of that and then push it out or push it around. Other things that I could upgrade, obviously I can put more drives in here if I want to. I can put a PCI card in here, and I'm thinking, you know, maybe the CPU will support 10 gig speeds for network, and that might be a good to add a 10 gig network card to that. There's other things I could do with that as well. I've got 128 gig of RAM. This board is upgradable to 512 gigs of RAM. Don't think I'll need that. I think that would be a waste for this board. Maybe 256 if you're pushing it. But I think I'm fine with this for now as it is. Trying to think if there's anything else. I mean, obviously I've got 3 more SATA connections there. We're going to put VLANs in place and firewalls and other things. It's going to be really cool to upgrade the lab. But this is really the good starting point. This will get me started. And hopefully we're going to put this on, power it up, and we'll see how well it works. And we're going to get on the SATA DOM. We're going to put Proxmox VE on it, the latest version. And there's my boot. My Samsung drive is going to start creating virtual machines and some Lexi containers, and we'll see what happens. That's it for this. So this is after putting this thing together, making mistakes, putting it back together, letting it run for a couple of days, and making sure that I can get software loaded on it, make sure that it's stable and kind of burning it in. So I have left the cover off of it in the rack to let it run, and it remains to be seen how much heat will actually be produced by this. But I wanted you to notice that I turned this around so you could see how the motherboard kind of fits in the back, where I've got the IPMI remote management slot and 4 gigabit network cards just built into the board, which I think is great. So I did the Samsung 990 NVMe drive incorrectly, stupid mistake, but it's kind of hidden here where this inserts. But if you look for it on the board, if you look close enough, you can actually find it right here on the board. And there's a little screw that's already mounted into the board where you can put it in there. So 128 gigs of RAM. I'm not using the CPU fan right now. I've noticed that it's 48 degrees Celsius holding for the CPU, which is well within range. We're going to put the top on it. We'll see how much it holds. If we need to put the CPU cooler in there, we will, the cooler fan. One thing to note is you will need both
this bigger power supply connector and the smaller power supply connector. This one connects the board to the machine to power it up. This one actually controls more, like for the IPMI, so you can remotely turn the machine off and on. I have found some issues with IPMI that I want to go over separately from this video. Found some security vulnerability issue deals, but we'll get to that later. Everything appears to be running, and if I needed more storage, I would put more storage in here, but I think I'm okay because my backups are working great. And also, I still have this PCI expansion slot, so I'm looking forward to using this. This is a very quiet machine, and if it remains so, even though I could have probably gotten a smaller case, I really like this case and having a little more air in there, and letting the air kind of move around and finding other ways to keep air moving. I'd rather have a bigger space, and I like just having a 2U rack-mounted server instead of like a small case that you might sit on top of something. So I really like the way this fits into the rack. We're gonna start plugging all this stuff in and let it run, and that's the first virtualization server build that I've done, and I'm very, very happy.
So there you have it, the agonizing tale of how a virtualization server was built in my lab. I've got the references in the show notes of the videos that I watched on YouTube and the creators that did that. And thank you so much for people who put great content out there on YouTube so that we can learn how to do this ourselves. I obviously don't know everything, and I'm still learning just like you are. So I wanted to share that knowledge with you. Do you think I made the right decisions on my build? Probably not. I know you're a vocal group, so I want to hear from you. I'm really easy to find out there on social media, LinkedIn, Twitter, Instagram, other places. If you click on that QR code and you scan it, you'll take you to my bio links out there and how you can get a hold of me, or you can just send me a quick email to heyscott@smcjournal.com. Would love to hear what you think about my server build and if I made the right choices or did I make wrong choices. Now remember, some of the choices that I made were because I was limited on what was available at the time. I mean, we're still dealing with some level of supply chain issues out there. Would I make the same choices now? I probably still would. Now, I actually want to build another virtualization server right now, and I'll probably use what I did before as a template and just maybe see if there's something a little better out there. But probably I could still use the same stuff. So if you liked this video and this helped point you in the right direction, it would be great if you gave me a like and you subscribe to my video channel so you can see more material like this and let me know that I'm doing the right thing as we train the algorithm together. So for this episode of the SMC Journal podcast, this is Scott Moore saying thank you for watching, and we'll see you next time.